Hello and welcome back to Train Signal. This lesson we're going to be going through configuring virtual desktops. So in our lesson today, we're going to be taking a look at what the best practices are for a parent VM, what that gold master image needs to look like, and how you can best put that together. We're going to look at different types of view desktops. We're going to be looking at pool configuration options that you're going to have when you're going through the process of creating your pools. Then we're going to take a little bit of a deep dive into understanding link clones and how all the pieces fit together to comprise what are called link clones. Then we're going to take a look at how to do pool sizing and understand that. And then we'll also go through the pool creation walkthrough as well. So, for our parent image best practices, our goal is to reduce CPU, RAM, disk, and network load, right? So when we're putting together a parent image, we're going to want to make sure that we're getting rid of as much of any idle cycles that are going around of CPU, RAM, disk, or network. Those all add up when we start compressing and putting lots of folks onto a single server. So when we're on individual workstations, we don't feel all that pressure. But once we start to consolidate and get 50, 60, 100, 200 virtual desktops onto a single server, then we need to make sure we're maximizing each one of those resources to its fullest potential. So a lot of our work is done around getting rid of any of those unnecessary items. And speaking of unnecessary items, we want to also remove and disable anything in the image that's not needed, right? So things that would be like this would be services. So a huge one I've seen out there a lot of times on Windows XP is the wireless zero configuration service. We're not going to be connecting to wireless access points in our virtual desktop environment, so there's no need for that service to be running. Turn it off. Themes, indexing, any of those types of services that are running in the background, they're just taking up extra CPU cycles or I/O away from your disk. Get rid of them. So let's get those off of the table, disable them, and test. Make sure this actually can be removed. Another nice hidden one, especially in Windows 7, are scheduled tasks. So things that you may not even realize that are actually running in the background, like defragmentation. So things that are scheduled and that are running as a job, it's a little easier to see it in Windows XP and use it that way. But in Windows 7, make sure you take a look into that, and it may surprise you to find all of what Windows 7 is doing in the background to make your experience better for you. So we want this to be the least common denominator, right? So we want this machine to scream and fly. So we're going to want to get this image down to just the least number of components that are possible to make it run and run really well. We want to eliminate visual effects, right? They look pretty, they look nice, we all like them. But when it comes to this, again, we're trying to eke out every bit of performance that we can possible in this image. So the first thing I do, right-click on my computer properties, go to the Advanced tab, and choose instead of letting Windows choose what's best for me or choosing for best for appearance, I want to choose for best performance. That'll automatically take away a lot of things that are unnecessary, of fading menus and a little bit nicer looking backgrounds or transparencies. So those kind of things can just go bye-bye. But if you're running Windows XP, you definitely want to make sure that you have your partitions aligned. So I won't go into the details of this, and you can definitely Google this. There's a whole series of documentation and blog posts that are out there on, if you just Google VMDK or VMware partition alignment, and you'll find all these articles. But basically what happens is, because of the alignment of the partition in its default setting, what ends up happening is that for every write that you're doing to the disk, you're actually having to write in two places because the offset for where those disk blocks are lined up crosses this boundary, which is going to cause double reads, double writes. So again, when we're trying to eke out performance, there may not be a lot of this actually going on as far as a penalty for you, but every little bit helps. So you definitely want to make sure you get your partitions aligned. And since we're going to be multiplying this right over and over and over, multiple desktops with the same image, we want our parent image to be aligned. We want to make sure it's at the right offset. For Windows 7, again, we don't have to worry about this. They've set the partition offset at 1 megabyte, so it's aligned by default. Nothing you need to do there. Now, there's lots of image optimization guides that are out there. There's some really good Windows XP and a very good Windows 7 guide from VMware, which actually includes some scripts along with it. Citrix has some, as do other folks out there on the blogosphere. So take a look and see what's out there for you and collect all that you can. And finally, with all those, test, test, test. Make sure that everything you're disabling isn't something that's a dependency for your applications. So with that, make sure that you've gone through and tested to make sure that your application doesn't have a problem with you disabling a particular service, or if you're not going to actually have a negative impact by turning off a particular setting that someone may say is a best practice. So it's always different in every person's environment, so no two environments are the same. So make sure you go through and test it out. All right, view desktop types. So number one, we have the individual desktop. The individual desktop itself is basically what it says, right? It's a virtual machine that's out there that we can connect to, and we can put a bunch of these together. But it's a one-to-one correlation between an individual and a desktop, and it's by itself. There's no linkage back to anything else. So not all that great, but it gives you an ability to be able to take a desktop and use VMware View to be a broker for that. I don't find a lot of value of this out in the field, but it is a way to take something like a physical desktop. I can put the View agent on and use that as a broker. So it's there as an option. Now the real magic there comes with pools, and with pools, each one of these sections are grouped together because it's an A or B option, an on or an off, right? So I can choose one or the other, but I can't have both in one pool. So in my pools, I get the option of having floating pools or dedicated pools. So with a floating type pool, that means that there is no correlation between the user and the desktop. So when you first connect, you may get desktop 01. The next time you connect, you might get desktop 13. The next time you might get desktop 04. So there's no guarantee that you're going to get the same desktop that you're going to land on. So it's floating. You float around to whatever desktop is there and is available for you. The second option with that is dedicated. And it's just like what it says. When you log on, you're going to connect into your desktop, and it's always going to be your desktop for the first time that you log in. So when the first time you go to log in to that particular pool, and it's a dedicated pool, you will be assigned to a desktop. Now, you can actually pre-assign users to specific desktops, or you can just let it happen randomly as users log on. The first desktop they log on to will automatically become their assigned desktop. Then our other option is automated or manual. So with automated pools, these are pools that are actually grown and shrink by the administrator control and by administrator setting. Whereas with manual pools, this is where I'm actually taking a group of desktops all together and pooling them together. I would essentially take them from a template and create them into a pool itself and then group them together and gather them together. Now with link clone or full clone, we'll actually do full clone first. So with a full clone pool, this is where I'm taking a full copy of an existing VM based on a template, and it's making an exact copy of that particular VM and multiplying that. So if we got example of a 20 gig Windows XP desktop, it's a 20 gig XP desktop, a 20 gig XP desktop, a 20 gig XP desktop, all pooled together with no relationship back to their original gold template other than that's where it got its original settings from. So there's no automatic updating to update those systems. If I want to do any type of an update process, I have to create a whole new pool of full clone templates with whatever update that I want, and then transition everybody over to the new full clone pool. Now the link clone pool, and we're going to dive into this in a little more detail later, so don't want to go too much into the weeds. But this is, again, where I get to take a master image, and based off of a snapshot of that master image, I'm then able to create a pool of desktops that are linked back to a read-only replica copy. So there's a read-only VM, and then there's a read-write smaller VM with only whatever the differences are between it and the read-only copy. Like I said, we'll get into a little more detail, so don't sweat it. We'll be more to link clones. And then finally, another desktop type that we have is terminal servers. Again, this is like our individual desktop type where it's kind of limited in function, but it does provide a way for you to broker terminal server access using View Manager. So that way I can entitle specific users to terminal servers, and that they're going to always have to go through the View Manager environment and be authenticated and make sure that they're entitled in order to be able to access that terminal server environment. All right, now we're going to take a look here at configuring View desktop rules and the associated settings that go along with that. So the first group of settings that we come across when we're creating a brand new View desktop rule is the naming conventions, right? So we have a naming convention for the pool. There's a unique ID which the administrator sees. Then there's a pool name that the end users actually see when they connect in. And then there's the also associated virtual machine naming convention that's associated with that. Now remember, there is a limit of 13 characters for this particular name because there is a two-number sequence, auto-sequencing number that appends itself at the end of the virtual machine name. And there's also some controls that give you the flexibility of how to control that auto-sequencing number and how many digits are in that number and where they appear within the virtual machine name. Make sure to look in the View Administrator Guide for those particular details of how to script that. Now, and another note to make notice of here is that the pool name and pool ID, so these are static entries that once they are created, you can't change them after the fact. So there are a lot of the settings within a pool which can be changed and manipulated after you've created your pool initially. Those cannot be. So once you've gone down that path, make sure you pick the right naming convention so that you aren't stuck in having to create a brand new pool. Now, there's a group of settings called pool settings. And inside of these settings, there's actually a plethora of different settings because they're kind of don't have a particular place, but they're associated with the pool itself. So these would be things like the size of the pool, how many virtual desktops are going to be the maximum for this pool, what are going to be the minimum number of virtual desktops available, what type of power settings, how are my virtual desktops handled when they're not in use, are they suspended, are they powered on, are all desktops prepared and provisioned up front, or are they provisioned on demand as needed and as the pool grows, the limiting and throttling of flash bandwidth, the PC over IP or RDP connection protocols that I connect over, and what my monitor screens are going to be associated for that. And what happens and how do I handle disconnections of sessions and when users are forced to log off and whether or not I need to do a refresh at any of those times to reclaim space if I'm in a particular link clone setting. So there's a lot of settings within that category and a lot of nerd knobs to be able to tune and tweak to make your images the way you want them to be. Now there's also a set of disk settings that are in our pool configuration, and there are different disk settings depending on which type of pool I've chosen. There's the persistent disk, which can redirect my profile data and allow for the ability for my profile to live on a separate VMDK file in a separate data store, so that I can make sure that that data is securely backed up and taken care of. There's the disposable disk, which allows me to redirect things like the page file and temporary internet files and things that would continue to cause a link clone type of a disk to grow over time. So I can redirect those files to a VMDK file that gets thrown away and deleted every time. I get to choose the disk settings of where these disks are going to be placed within my data store infrastructure. So I have the option of being able to tier these particular disks depending on their read and write requirements. So depending on whether I've got something like a link clone replica, which is a read-only VM, I might want to put that on SSD drives to make use of high read IOPS that I would get off of that for that particular replica, while all of my link clones can live on maybe slower SAS or SATA disk. Again, your mileage may vary, but there's a lot of options there for tweaking and tuning that depending on the type of pool that you're creating. Then we have the pool sizing options. So those pool sizing options are how big is my pool going to be, right? How many desktops are going to be allowed? What is the maximum amount? What is going to be the minimum count number? And how am I going to handle and manipulate that sizing? Now, I'm going to either have a template or a parent image depending on the type of pool that I'm configuring. If I'm in a manual type of pool, then I'm going to be basing that off of a template, or a full clone environment is going to be based off of a template that I need to have already pre-prepared and ready to be able to use. Whereas if I'm in a linked clone environment, I'm going to have a parent VM and an associated snapshot along with that parent VM that need to be set up and configured in order to deploy virtual machines from those. I also get to select the placement for those virtual desktops within the virtual infrastructure. So which hosts do they get to run on? What resource pool? What data stores? What virtual machine folder structure? So all of those options are available to me to show where to place the virtual desktops in the existing virtual infrastructure. So connection server restrictions or tags, what these are essentially text strings that I can place on a connection server and associate them with a desktop pool. And what this does is it forces the traffic for those particular desktop pools to utilize the connection servers with those tags and those tags only. So it allows me to direct traffic down a certain specific set of connection servers, or kind of the opposite of that, keep traffic away from specific connection servers or particular subnets that I may want them to come in from or not come in from. Now I also need some guest customization options. Again, if I'm going to be going the full clone route, then I'm going to need the guest customization from the virtual infrastructure to provide for that. Whereas if I'm using link clones, I'm going to have options like sysprep and quickprep to be able to provide for guest uniqueness factors. And then the final section that I need to handle is entitling of users and groups to a particular View desktop pool. So ideally I want to be using groups and staying away from individual users, but for smaller environments that might be okay for you. But as you start to scale, you're really going to want to create groups of users based on the particular pools that you're having them connect into, and then just controlling access through those groups. So let's jump right into Composer link clones and kind of do a little bit of a deep dive here. So a Composer link clone at its very base originally starts with a parent VM with at least one snapshot. So what I have is a virtual machine, not a template, but a regular standard virtual machine that I've configured as my golden image. And then when I'm ready, and I think I've gotten this golden image set exactly the way I want it, I'm going to power that off and take one snapshot. And then that's going to become the basis for my link clone. What's going to happen is when I then go to deploy a link clone pool, it's going to take that snapshot from that parent VM and make a full clone replica off of that. So this is a thin provisioned full clone based off of that snapshot. So it's thin provisioned to save on space, but it's a full clone and it's isolated from that parent VM. So there's no longer a relationship between that parent VM and snapshot other than to say that was the origin of this replica. But the replica stands by itself and it's a read-only copy. There's the option to have a replica per pool or one per data store. So the reasons behind this is it's going to provide a replica for each data store and the link clones associated with that data store. Or I'm going to have one per pool and I'm going to tier it, like I was mentioning earlier, by having that, like say that replica on fast SSD disk or some other type of faster storage to provide a higher tier for that. Then the individual VMs. So these are the linked clones. So they're comprised of a delta disk, potentially a persistent disk, and potentially a disposable disk. So the delta disk is required. And what that is essentially the unique factors that make that virtual machine or link clone different from the replica. So these would be things like the virtual machine name, its IP address, SIDs, all those types of factors. And over time, it's going to continue to grow as it writes to the C drive. It's not able to modify that read-only replica copy, So it's modifying that individual delta disk for each individual VM. And over time, that delta disk is going to grow as log files are written to the C drive, or other things are written or changes are made to that C drive which differ from the original replica. Now, the persistent disk, as I mentioned earlier, is actually a way to be able to redirect your profile data onto a separate VMDK file. So if you chose that as an option, then your profile will live on that persistent disk, and that persistent disk is protected from other types of operations you may have, like a refresh or recompose in a link clone environment. So that data is kept safe in that instance. And then there's also the option for having a disposable disk, which is temporary internet files or page file, things that are transient in nature that would cause that delta disk to continue to grow. You can redirect that data to a disposable disk, so that way that data gets thrown away every time. It doesn't actually cause the delta disk to bloat over time as much. Link clones are going to be able to use QuickPrep. It's a quicker alternative to SysPrep. Essentially does the same functions, but it's much faster and much quicker in the process. And so therefore your VMs will get provisioned much quicker. We also have the option for doing storage overcommitment with these. So we can select to have no overcommitment, to be conservative, all the way to aggressive. And what this is how many of the virtual individual VM link clones do I want to try to stack on an individual data store, and how dense do I really want to get that. And as I mentioned earlier, there are 3 different composer operations. I like to call them the 3 R's: the refresh, the recompose, and the rebalance. So the refresh is essentially taking that delta disk and reverting it back to its default setting and size. So that way, over time, as it starts to grow, you can kind of control that bloat of that delta disk by doing a refresh operation. A recompose allows me to change the snapshot that the entire image set is based on. So if I want to make changes, if I want to do things like add another application to my pool, or update a service pack for a particular application, I can do that to my parent VM, create a new snapshot, and then do a recompose and point back to that new snapshot and update the rest of the pool, creating a new replica and new individual VMs in the process. The rebalance operation is essentially a way to be able to be as fair as possible, to have as many virtual machines across multiple data stores and not have one data store stacked higher with virtual machines than others. So since we don't have the ability to use storage vMotion for virtual desktops, this is a way to be able to control that and to even out or balance out the data store sizes. All right, so let's look at the persistent disk now in a little more detail. So the persistent disk, as we've spoken about, it preserves the user profile data during composer operations. So what it does is a redirection essentially to a separate VMDK disk drive to isolate it from the rest of the operating system itself. So whenever I'm doing a recompose or a refresh, it's not a destructive event to the profile, because usually your profile would be under something like C, user documents and settings, blah, 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 your username. So that's underneath that C drive, so that would actually get reset to default. So anything you had on your desktop or your My Documents would go back to whatever it was prior to logging on for the first time. So you'd lose your data if this wasn't put into place, or something like roaming profiles or some other profile management solution wasn't put in place. So this contains, like I said, our user profile and our My Documents data. So everything that you're going to find in there that's going to be specific to your particular profile, to your particular environment as a desktop. The other nice feature about this is I can actually detach this disk from the View Desktop. So if I need to take and move this persistent disk somewhere else, I can do that. This is one of the caveats of the persistent disk that I don't like, is the fact that it's per pool. So if I am a member of 3 or 4 different pools that I'm entitled to, and I have persistent disks in each one of those pools, I'm going to have a separate persistent disk in each pool. So I don't have a single common persistent disk that I share across pools. So one of the downfalls of the persistent disk, but it is still really a great feature to have and really easy to configure as far as being able to isolate and separate that user profile data. Now, when you go back to reattach the persistent disk, you need to make sure you're doing it with the same operating system. So this isn't a get out of jail free card for a way to upgrade your user profile from, say, Windows XP to Windows 7. You're still going to need to, it's a totally different world between the two, and you need to have some type of profile migration solution or go through the path of upgrading from XP to Windows 7 in order to get your profile to migrate across. So the disposable data disk now. We mentioned it slows the growth of the link clone delta disks, right? So it's going to contain files like the paging file, temporary internet files, temp files, those things that are very transient in nature that we don't need. And it's going to take those and it's going to throw those files away whenever the desktop is powered off. Now, it's stored on the same data store as the link clone disk, so there's no way to be able to control where this actual particular disk lives. So you're kind of stuck with that, but that should be good for most environments and shouldn't be a problem at all. So let's take a look now at pool sizing in a little bit more detail. So some of the items that you're going to get within a pool sizing setting arena. One is the minimum number of desktops. So these are the desktops that View is going to ensure that at least this number of desktops will be deployed, will be there, and will be ready. Now, you kind of alluded to this, the number of spare desktops or powered on desktops. So this is the number of desktops that will be ready for immediate connections. So if I don't do anything with my power policy settings and leave them at their defaults, and we'd mentioned those before for a pool, and I go to here and I say I want a minimum of 10 desktops, and I say I want at least 3 desktops as spares, I'm going to have 3 desktops that are powered on. The rest of my desktops are going to be powered off. So once I get to the 3rd desktop and someone tries to go to connect, then it's going to have to wait and power up the VM before the user is able to connect into that VM. May not be the experience that you want for your end user, so just be aware of that. Then I've got my maximum number of desktops. So this is going to be the total max desktops that I'm going to have for this particular pool. Now this number may need to be greater than the actual number of licenses that you're entitled to. Now remember, the View licensing scheme is based on concurrent users. So the reason for this is operationally, if I'm doing any type of migrations or as I'm having and bringing on users, I may need to have enough desktops that are ready and pre-provisioned and ready to go greater than the number of licenses that I have so that those desktops will be available and ready to go. Now, the power state of unused desktops is based on the pool power policy and the number of spare desktops. So both of these factors are taken into account. So as I mentioned earlier, if you don't do anything by default with your power policy in the pool, then they're going to be left powered off. But there is an option to say, I want to ensure that desktops are powered on. So if that's the case, that's going to make sure that whatever the numbers that I picked here, I will have, as long as those desktops are set to be deployed, they will be powered on and ready to go. So let's take a little look at a pool sizing example, kind of flesh this out a little more, give it a little more skin to it. So let's look at pool provisioning settings. I have a minimum number of 10 VMs. I have a maximum number of 100 VMs in this pool, and I want a spare set of 5 VMs. And my power policy that I've set for the pool is to suspend VMs if they're not in use. So what happens? With 0 users, I'm going to have 10 VMs that are deployed, 5 that are powered on, because the spares are what get powered on unless I have a setting in my power policy otherwise. So when I add 5 users to this, there's still only 10 deployed, but now there's 10 powered on because I have 5 people that are using those VMs. I need to be able to have ease of use for 5 additional desktops to be ready to go, already powered on for users to connect to. Now what happens when I get that 6th user connected? Well, now I have to deploy a new VM, so that's where my next 11th one is deployed, and that 11th one is deployed in order to keep up with the 5 spares that I need to be able to have available. So now that I've done 6, I would only have 4 spares if I left it without having any other desktops provisioned. So now it needs to actually provision and power on that other desktop, one more desktop, in order to allow me to have my 5 spares. Now, if I have 97 users, there's going to be 100 VMs that are going to be deployed. So now I'm kind of violating that 5 spare rule, but that's because I've hit the 100 max. So I've got 100 max VMs that are actually deployed, and therefore 3 extras that are powered on available. So I don't have my 5 spare, but that's because the maximum setting is enforcing that. All right, now that we've walked through the pool sizing example, let's actually do a walkthrough of the actual pool creation process. Go through and create a couple of different types of pools so you can see how it looks and feels as you go through that. So with that, I've logged into the View Administrator, and I'm going to click on the Pool section underneath Inventory. So as you can see right now, I don't have any pools listed available currently, but let's go ahead and add one in. And to start off with, let's actually choose a manual pool. This is probably one of your less frequent types of pools, but it definitely does have its place. And we'll click Next. And for this one, we're going to be using this for our IT administrators. So we're going to do a dedicated pool assignment, and we're going to allow for Enable Automatic Assignment, so that way when the user logs in, they'll be associated with a virtual machine, and they'll always get that same virtual machine all at the same time. Now these are vCenter virtual machines. These aren't physical computers or terminal server, so with the agents, the View agent on them, so we're going to leave the default of vCenter virtual machine selected. And then we're also going to choose our virtual center server. We could have multiples. And we're going to put in our pool ID. And for this, we're going to say IT admin. And one thing just to notice, within the ID section, you can't have spaces. So if you do, you'll notice there's a little red box around it. It's letting you know there's something wrong. Okay, and if you keep hovered over it, it'll tell you all the information about the pool and what the character limits are. So let's get rid of our space there. And if we leave display name blank, it's going to just fill that in with the pool. So I'm going to actually be a little more descriptive, saying IT administrators. And we'll leave it in the root folder. And we'll go ahead and click Next. So here we get our pool settings for this particular type of pool. We do want the pool to be enabled, and we're not going to be doing any connection server restrictions via tags. Now for this, we do want to ensure that our desktops are always powered on and available for us. We're not going to actually log off after disconnect. Since this is our IT administrator's box, we're going to leave that selected as never. And we do want them to have control of their desktop, so we do want them to be able to reset their own desktops. Now you'll notice here we have the default display protocol set for PC over IP, and we have allowed the users to be able to change between PC over IP and RDP access. Now you'll notice under here Windows 7 3D rendering, which is currently grayed out. The only way to allow for that selection process to not allow users to choose their protocol and leave PC over IP selected. From that point, then you can enable the process and configure the amount of virtual memory that's needed for the 3D performance extensions. We don't have this as a need for our IT administrators, so we're just going to allow them to choose their protocol. And we're going to leave the max number of monitors set at 2, and 1920 by 1200 is perfectly fine for a display resolution. And we're not going to do any flash quality or flash throttling for these desktops. We'll go ahead and click Next. So it then looks and sees which virtual machines within Virtual Center actually have the View agent installed and are candidates for that. So I've got my Test01 and Test02 virtual machines that I will go ahead and use for this process. And it wants to make sure that we're correct, and we'll go ahead and click Finish. And notice the pool shows up, everything looks good. We're only missing one thing by default when we have pools that are created. they are not entitled to a particular set of users by default. So if we go ahead and click on the pool itself, it'll give you a little warning message letting you know you need to change your entitlement. So let's go ahead and do that now, and we will add the view administrators as being entitled to this pool. Alright, and now we're good to go. And because the systems are already there and in place, it's just going to go through and wait for the actual agent to come up so that it can communicate. And once it does, it will go into an available state. And there's nothing else we need to do. So we're good from that standpoint. And now you'll notice our check mark for the entitled has come into play. All right. Now for our purchasers, we're going to do an automated pool this time instead of a manual. And we're going to choose dedicated as well for them. And we will also allow for the enable of the automatic assignment. So these are going to be View Composer link clones. And we'll select our virtual center for that. And I'm going to say purchasers for our pool name. And I'll allow the display name to be the same. Alrighty, and for our particular systems here, again, for the remote desktop power policy, I'm going to ensure that the desktops are always powered on or suspended. Either one of those two are usually good choices for my desktops to have quick availability for my end users. Suspend allows me to not use up as many resources. But in this case, I'm going to leave them powered on. And I am going to automatically log off these users after a certain period of time. So this allows me to kind of control how long they're actually disconnected for. So in this case, 120 minutes, 2 hours worth of work, they should have come back to their system to resume any work if they've disconnected. If they're longer disconnected for that, then I'm going to automatically have them log off. And I am going to allow them to be able to reset their desktops to allow them to provide some control. And then I am also going to set their refresh of their OS disk to refresh every 7 days. So that way it's going to take that default disk, and we've gone through the 3 R's of Composer, so it's going to refresh it back to its default state every 7 days. We're going to leave PC over IP as our protocol. You're going to allow the users to select the protocol just like we did in the IT administrators group as well. So now you notice we've got some different options for this because these are link clones and this is a dedicated floating assignment. So we do want to have a persistent disk for this. I'm going to change this one in this case actually to 1024. This will house all the profile data, and I get to select which drive letter that I want, and I'm going to leave D selected as my default. And I'm also going to redirect my disposable files to a non-persistent disk. And this one I'm going to set to 2048 because our memory requirements are not that high, so I won't be running into a problem. Do make sure that whatever your page file, it's going to be at least need to be larger than double your page file. So we're going to, from a provisioning perspective, since there's an actual provisioning process in this pool, we're going to enable provisioning, and we're going to allow it to stop provisioning on any particular error. And we're going to use a naming pattern. So in this case, we're going to say perch dash FD for floating pool dedicated. And then I'm going to have a numerical sequence that I'm going to want. And I'm going to use n colon fixed equals 2. Now you can look in the administrator guide for view to learn the different options you can do to allow for where you would allow your numerical screen to come from within the naming pattern and what different types of options. In this case, I'm just saying I want it to have a fixed character set of 2 characters for the numerical sequence, so 01, 02, 03, so on and so forth. And for this one, our maximum number of desktops is going to be 2 And I'm going to make sure that at least one of these is powered on. And it's going to go ahead and provision all desktops up front. Select next. All right, now we need to look at what our default image is going to be. So we're going to browse out to that. So remember, this is our parent VM that we are going to be basing this off of. Click OK. And I actually have two snapshots in here. We're going to go with the initial snapshot for post-VM optimizations. Click OK. And then now I'm going to select a folder within the virtual folder hierarchy. Click OK. The host or cluster that it's going to be a member of, and the resource pool, which we're just going to be using the root of the host cluster, and then the data store that I'd like this to live on. I'm going to go ahead and put this on my NFS data store. And I'm going to leave the storage overcommit set to conservative. I could be more aggressive with this to allow for more link clones to be able to be processed on this, but I'm not going to do that in this case. Now I could do different OS data stores for the OS and the View Composer persistent disks. So what this would allow me to be able to do is to select a separate data store if I wanted to in order to put my persistent disks on. This allows me to separate and segregate the OS disk and the persistent disk. That way I know which data store the persistent disks will be located on. I can get them backed up. That's really important. Another reason for doing that would be tiering of storage. So I may want to provide a higher level of read or write performance for a particular one over another. And then the same goes for the replica disks as well. So this allows me to put the parent image on a single high-speed performing disk. And what that'll actually do is make sure that it is on a disk that is high performance. But in addition to that, change this here. And we'll specify that for replica to show the difference. And now what that would allow me to do is leave one set of data stores for link clones and a single data store used for replica disks. In its default mode, if we leave this unchecked, what's going to happen is that every data store that we have selected, so if I had multiple data stores selected, it's going to create a replica disk on each data store. So if I check the box to use a different data store for the View Composer replica disk, I only have one replica. So it does save on some space as well as allowing you to tier it, put it on a higher performing disk. So for right now, I'm just going to choose the one data store for everything. We'll say OK and click Next. And then finally, our last step is to choose whether we want to use Quick Prep or SysPrep for our customization process, and to tell it the AD container we want it to dump into. By default, you don't want it to dump into the computer's container because it's not an OU, and you can't control group policy settings for any objects that are contained within it other than from the domain OU, or excuse me, the domain group policy. So we're going to put this in the vDesktop's OU, so that'll allow us to be able to use any group policy objects attached to that OU to specify settings just for these virtual desktops. We'll go ahead and click Next. Asks us to confirm all of our information, and we'll go ahead and click Finish. And again, it starts off with the same way. If we go to look at this pool, it's going to complain to us that we need to make sure we have it entitled. So we'll click the entitlements, and we'll add the purchasers group to that pool, and click OK. And there we go. And if we go to look over in our inventory, there's currently nothing here right at the moment, but in just a few minutes it's going to spin up virtual machines, and you'll start to see their statuses change from here as they go through the process. And if we were to go over and look at Virtual Center itself, Like I mentioned, in just a few minutes, it's going to kick off the task within Virtual Center to start creating the replica disk, and then finally the link clones disks as well. And there it goes, starting the process of cloning the virtual machine from the parent disk. And it'll copy that. If we come back over to our View Administrator, I'll do a refresh. We now see that we have our two desktops that are currently unknown because they haven't come up yet, but they're in the provisioning status. And so you can continue to refresh this, the status on this as it goes through the process. And once the view parent image is completed copying, which will take some time, depends on the size of your view parent VM. It's a full clone replica, and obviously the speed of your storage as well. It will then copy that image over, and our link clones will proceed. Fantastic. I hope you enjoyed that walkthrough of the creation of the manual pool and the automated pool process. Alrighty, what have we covered here today? We've taken a look at the best practices for a parent VM and for an image and what we want to see in that image. Remember, we want it to scream. We want this thing to be fast, trim, lean, and mean, and do just what it needs to do to provide applications and data to our users. We've looked at the different types of View desktops and the different selections that we have for those. We've looked at what our pool configuration options are and to see all the myriad of choices that we can have for our different pools and what settings and how those can impact and affect one another within the pool. We've also taken a look at the understanding of link clones and a little bit more of a deep dive onto how that process is put together and how that architecture is tied together. And then we've also finally gone through a pool creation walkthrough so you can see what it looks like to go through a couple different instances of pool creations. Thanks so much. You have a great day.